Check, check. I'm hoping that y'all can hear me. Let me know if you can hear me just fine. Let me know if the sound quality is okay. Check. All right, so let me know if you guys can hear me. If not, I'll kind of like move things around so that it's pretty clear. But today, we're going to go over some free response questions for the AP Calc AB exam. So I know a lot of you guys have the exam coming up in about, what is it? Today's the 22nd. It's on the 13th. So 3 weeks, I guess you can say. Okay. But yeah, I'm pretty excited. So just so you know, if you guys, happen to leave, I'm going to post a replay of this video on my YouTube channel so you guys can watch, you guys can practice along with me on these problems. Whew, it's a little hot, but I hope everyone's doing well. I know it's a little late. It's been a pretty long day for me, but I promised myself that I was going to go live and go over some free response questions for the AP Calc AB exam. So typically there's 6 questions and it's divided up into calculator, no calculator. For this one, for example, it says a graphing calculator is allowed. So I believe starting from problem number 3, a calculator is not allowed. So we're going to do the first 2 problems with a calculator. I have my TI-84, and then the rest we're not going to do a calculator. So I'm going to try to get through most of them. I hope that I do all 6, but if not, I mean, at least you guys got some practice in. All right, so let's go ahead and talk about the very first question. It's talking about an object that's moving along the x-axis with its velocity given by this weird equation where t is measured in seconds and it's from 0 to 5. So the object's initial position is x is equal to 8. So we need to know these things. So the very first thing that they want to find, or they want us to find, is the acceleration of the object at time is equal to 4. Now, even though this is a calculator portion, I believe they are going to want you to actually take the derivative of this, or at least show some of the steps. So if we're going to find the acceleration, don't forget that we're going to take the derivative of this function right here. So let's just go ahead and do this on right on top here in option A. So don't forget that the velocity, or the derivative of the velocity, is the acceleration. And we're going to use the quotient rule here. 1 plus t squared times the derivative of this function here. Geez, I didn't account for not having enough space, my bad. So now I'm going to subtract the first function, 2 sine of 1.2 t cubed, and then times the derivative of that, which is going to be 2t, all over 1 plus t squared. And now our job is to plug that into the calculator, okay? So we're going to go ahead and take the derivative, which I just did. That gave me the acceleration, and they want us to find the acceleration at time is equal to 4. So you just go ahead and plug in 4 into this function here. For the sake of the live, I'm not going to do that, okay? It's pretty easy. You just use your calculator, plug it in, and one of the things that you might want to put is the correct units. So velocity is measured in, it looks like... It doesn't say anything. It's just measured in seconds. Wow. So this book is probably not the best. But anyway, you have to put like meters per second squared or something like that. Okay, so now we're going to go on to part B. This is the important one. They want us to find the position at time is equal to 4. And the way we're going to do that is we're going to take the integral of this. But we don't really want to get too messy with this. All right. One thing they do tell us is that the position at time is equal to 0. So in the initial position is 8. We're going to use that to our advantage because for part B, we're going to take the integral from 0 to 4 of the velocity function, okay? Because this, according to the first fundamental theorem of calculus, is going to give us a position at 4 minus the position at 0. Now, one cool thing is we already know that the position of 0 is equal to 8. That's what they told us. So this integral from 0 to 4 of the velocity is equal to the position at time is equal to 4 minus 8. So whatever this value is, which is going to be the integral of this function up here, we value it from 0 to 4, we're just going to add 8 to the other side. Okay, so for this particular time, or this instance, I'm going to go ahead and take the integral here. So math 9 from 0 to 4, and then we want the function here. Now you got to be careful. Okay, one, you got to make sure that you're in radian mode, which I made the mistake of not doing that the other time. And also, even though this particular problem is in terms of time, you can't put the t variable here because it's not going to accept it. So we're just going to use x. So that's this, and then divided by 1 plus x squared. And they're banking on you making some mistakes when you write these problems, okay? And it is integrating. Here we go. So 0.49. Okay, so we have 0.494. I'm just going to truncate it. Position is the position at 4 minus 8. So I'm just going to add the 8 to the other side. So we have 8.494. And again, they didn't add a units, but I'm just going to go ahead and do that for us. So this is the position at 4. That's how we're going to do that. Okay? So now let's go to part C. What is the distance that the object travels on the interval 0 to 5? We got to remember the equation for distance, okay? There's two equations that we should know, distance and displacement. In fact, it gave that for part D. Distance, don't forget, is going to equal the integral from 0 to 5 of the absolute value of this particular function. Okay, whatever that is, we're going to plug that in for part C. And for part D, displacement is literally just the integral from 0 to 5 of the velocity function. Okay, so pretty simple. Okay, I'm going to go ahead and plug that in just for the sake of us understanding that. So for displacement, I actually already have the equation here. I just need to change my parameters. Whoops, I don't know why a tangent showed up there. So let's go ahead and change it into a 5. And it should give you my answer, which is going to be Come on. It's thinking. Wow. Geez, that's small. So it's almost the same thing, 0.494. Very weird values here. Or very weird just values in general. This is not a college board. This is actually a Princeton review. And these, these are, though they are really good to practice with, sometimes the questions could have like some typos, but it gets the job done. Okay, so for this particular value, all you have to do is, again, go to your calculator, and now you're going to go to math 9. So integral from 0 to 5, and check this out. We got to make sure that we put the absolute value, okay? So I went to math, and I believe, where is my absolute value? It's a number, and it's the very first one. So absolute value, and then this is where I have to put our equation. So 2 sine of 1.2 x cubed, close that, over 1 plus x squared. I got to make sure I close that. Okay, and here we go. It's going to find our answer. Hell yeah, Pen, what are you talking about? 1.13, there you go. So it's very important to know the difference between displacement and total distance. So 1.130. You can truncate it because in the AP exam, you can just stop at 3 decimal places. Okay? By the way, if you guys have to go, don't worry. I'm going to post the replays on my YouTube channel where I have other AP exams that I have done. And this week I'm going to complete 4 or 6 essential FRQ questions for the AP exam. So be on the lookout for that. Okay, that was part D. Now let's go to part E. If a different objects along the x-axis with its position is given by this, at what time are the two objects traveling with the same velocity? Well, this is the position function for this particle. So we're going to go ahead and find the velocity by just taking the derivative, because remember, the derivative is equivalent to the velocity. And that's my velocity. And they're asking when are these going to be equal to each other? Okay? That means that we have to set this equation equal to this one. And the way we're going to do it is we're going to graph it. Okay? You're just going to graph these functions. Pretty simple, I would say. So let's graph the first one. So 2 sine of 1.2 x cubed, and then close, over 1 plus x squared. Okay, so that's my first graph. And then the next one is just this function here, 3x squared minus 2x. Okay, so we're going to graph it. Oh, looks like I got to change my window. I was probably doing a different problem on here. Okay, so let's go ahead and change my window to -1. Let's just do like 2.5, and let's change our scale here. Let's do -1, 2.5. I think that's going to be a little better. Okay, so that's the first graph, and then there's a second. So it looks like it's probably intersecting at the origin, which is probably going to be true. You can check that. But in order to find the point of intersection, we're going to go to second and then calculate, and we want intersect. So we've got to move our function really, really close to the point of intersect, which is here. That's the first function. Move the second one a little closer. And our point of intersection is that right here. So 0.9, 3 decimal places, 0.980. Okay, so time is equal to 0.980. And I believe the other one's going to be t is equal to 0. You can just see it. That is touching at the origin. Okay, that's the first question. Honestly, I feel like this one was a little too easy, but let's talk about some other ones. All right. And by the way, if you enjoy this, feel free to follow me here on TikTok and on Instagram. I'm always posting videos for AP Calc, especially now that it's coming up in May. Okay. So here's the next problem, okay? People board a train at this rate. So this is, the blurriness is not good. Okay, so here we go. People are boarding a train given by this function here, okay? So this is the function for 0 to 10, where b of t is measured in people per minute and t is measured in minutes. And then as you can see, this is the equation from 0 to 10. And then after that, it looks like no people are boarding. And as people board the train, they exit at a constant rate of 3.2 minutes, 3.2 people per minute. This is important, okay? Because this is people entering, and I'm just going to put exiting. So I'm just going to write an equation for that, okay? I have a feeling that's going to be very helpful or essential, because this is going to be a question where it's like, what do they call this? Like entering, exiting, okay? And then don't forget, there are initially 30 people on the train. So these 3 things are going to be very important. So let's talk about the first question. How many people board the train during the time 0 to 10? Well, they're asking to take the integral of this function. Looks like it's a little blurry. I'm sorry. It looks like you're going to have to take the integral of this function from 0 to 10. And I didn't even write the equation. I just put integral from 0 to 10 of b of t. And again, you're just going to plug this into your calculator. Whoops. Let's go back over here. Math 9, 0 to 10. And we're going to plug in that equation here. So 1800 x over 10 to the power of 2, and then times 1 minus x over 10, close parentheses, to the power of 3. Okay, and then let's go ahead and close this. And we get an answer of 300. That's a really nice number. Okay, so 300 people. So that means that between, it looks like t is minutes. So between the first 10 minutes, between 0 minutes and 10 minutes, 300 people entered, okay? But don't forget, at the same time, there's people exiting, and then there were already 30 people there. But we answered the question for part A. All right, so for part B, how many people are on the train at time is equal to 10? Okay, this is very similar to one of the problems that we did previously, okay? Well, we know one thing. We know that there's 30 people initially. Okay, so what we're going to do is I'm going to create an equation, and this is where it's going to be important for us to know this. I'm going to call it P of t. Why P? I don't know. Okay, and what I did here is I put the total number of people is going to be determined by 30 plus the integral from 0 to t of this particular function that we have, minus the integral from 0 to t of the function 3.2. Okay, because what I'm doing is I'm taking the number of people that were there plus the number of people entering minus the number of people exiting. Okay, that's going to be extremely important for us to know. So the reason why we're doing this is because we want to know how many people are there at time is equal to 10. Okay, so all we have to do is we want to know how many people are there at time equals 10. So we're going to make that our t equal to 10. And I'm sorry, by the way, if you hear a dog barking. I hope you know. Okay, so here we go. So this is going to be the integral 30 from 0 to 10 of b of x dx minus integral from 0 to 10 of e of x dx. Okay, so here we go. We're just going to put this into our calculator. So we have the 30 plus, and then we have the integral from 0 to 10, which, by the way, we found out in part A. So we know that's going to be 300. So I'm just going to put 300 minus, and then I'm going to go ahead and put the integral from 0 to 10, and then 3.2. There we go. X. So 298. At time 10, that's how many people there are. That's crazy. Only 2 people exited. Oh, total. So that's going to be 298 people. All right. Hold on, guys. Give me 1 second. My dog won't stop barking. Okay. I think I took care of that. Sorry. All right. So here we go to part C. No one boards the train after time is equal to 10. So what time will there be no people on the train? Well, don't forget, at time equals 10, there's 298 people. So we just got to find out how many people or how long it's going to take for people to leave for us to have 0 people. Now, don't forget, this is our equation. Okay? This is how many people are exiting. 3.2 people per minute. So we want to know how many minutes until this value is equal to 0. So we're going to move the 298 to the other side. And then we're going to divide by negative 3.2. And we get that it's going to take us about 93.125 minutes. Whoops. Let's go ahead and put minutes there. There you go. Okay, and then here is the next question, part D. At what time t is the number of people on the train a maximum? Well, this represents the number of people, okay? And what we want to know is we want to find the maximum. In other words, we want to find the derivative of this and take it equal to 0 because we want to find the critical point. So let's go ahead and do that. I'm going to take the derivative and check this out. The derivative of the constant is 0, so that's going to go away. The derivative of this integral by the second fundamental theorem of calculus is literally just the function. So this is just going to be b of t minus the value of e. So minus e of t. So really what we're trying to find is when is this function up here equal to this function up here? And why is that? Because again, if we're trying to find the critical points, we're trying to see when is b of t minus e of t equal to 0. In other words, if I bring the e of t to the other side, we're asking ourselves, when is e of t equal to b of t? And in order for us to do that is to go ahead and graph that, okay? Oh, I don't have the graph here. Okay, so let me go ahead and graph it. So the first one that I'm going to graph is just 3.2 because that's how many people are exiting. And then the next one is going to be this function up here. So it's 1800. Oh my goodness, x over 10. This is honestly why what makes the calc exam so difficult is that sometimes they trick you with how you have to write things and you have to make sure you write it correctly. But here we go. Okay, it looks like there's only 1 point of intersect here. That's crazy. It's a 5th degree polynomial, but it looks like that. Okay, so once again, if we want to find the point of intersect, second calc, intersect. And then we got to move our function really, really close. This one. Whoops. Maybe I can move it closer. So point of intersection 0.45. Okay. So t is going to equal to 0.451. Now, one of the things, typically on the AP exam, they're going to tell you to justify your answer. All right. Well, we found this. We did all the work, and we're showing that, okay, if we took the derivative, we found the value of t where they're equal to each other. And by the way, if I look at this, if we look at our graph, there's also another point of intersect here, but this time is going to be negative. So we don't really care about that. We just care for values where the time is positive. Okay. And now at this point, we want to know, okay, is this, or we want to show that this is a maximum. It looks like it's the only value, so it should be a maximum. But in order to do that, we're just going to go ahead and test the number line. Okay. This is 0.451. So we're going to test the value. Let's just say t is equal to 0.2, and then we're going to test t is equal to 0.5. And we're going to plug that into this value here, b of t minus e of t. And the reason for that is because we want to know if this is truly a maximum, then this should be positive because the function should be increasing, and it should be negative. Okay, so we just want to make sure it alternates. So the way we're going to do that is we're just going to plug in 0.2 into this function and subtract it from 3.2. So what I want to do is I want to check b of 0.2 minus 3.2, and I just want to make sure that's going to be positive. So let's go back to our problems here. So 1800 times 0.2 over 10 to the power of 2 times 1 minus 0.2 over 10 to the power of 3 minus 3.2. Oh, that's not good. It gives me a negative value, so something is going on here, okay? And I'm honestly going to blame it on the Princeton review, but if you guys see something else that is not going well or that doesn't look right, let me know in the comments or let me know in the videos if you're watching the replays. But I have a feeling Princeton review is known for making some very, very silly mistakes when it comes to this, so I'm going to blame it on them. But if I'm wrong, please let me know, okay? We're going to move on to the next section because I want to get through at least 4 problems before I call it a night because I know it's getting a little late on my end. Okay, so here we go. So now no calculator. We are officially not using it, so that's it. Now we're just going to use pen or a pencil. All right, so here we go. So grain is filling a container that is in the shape of a right circular cylinder with a diameter of 4 feet. What? Well, first, let's just go ahead and draw that real quick. I think typically if they give you a problem like this, okay, I think they should have given you a picture. But it's a right circular cylinder with a diameter of 4. So, right circular cylinder with a diameter of 4. I'm just going to give it a radius of 2 because they talked about the diameter of 4, but I'm just going to say the radius is going to equal to 2. Okay? The rate of change of the height of the grain is modeled by this equation. dh dt is equal to 12 root 4 plus h, where h is measured in feet and t is measured in minutes. Okay? Find the rate of change of the volume of grain in the container with respect to time when h is equal to 12. All right. I don't know if you noticed already, but this is a related rates problem. Okay? So we got to find the volume of this shape. This is going to be the volume. Okay, pi r squared h. Now, notice one thing here, okay? The interesting part about this is that if this is being filled, okay, it says it's being filled with grain, but just imagine, okay, if it's being filled to the top or if it's being filled in the bottom, it's always going to have this right circular shape, so the r is always going to be 2. So the r is never going to change. In fact, we can already change this r into a 2 to make it pi 2 squared h. In other words, 4 pi h. Because from here, we can go ahead and take the derivative now. Because they want us to find the rate of change of the volume. So they want us to find dv dt. So if I take the derivative in terms of time, this will become dv dt equals, and now I go ahead and take the derivative of this. 4 pi is just a constant, so I really just have 4h, or not 4h, I'm sorry, 4 pi dh dt. And dHdt was given to us by this value up here. So this is 4 pi times 12 root 4 plus h. And I'm just going to leave it like that. And they want us to find this rate, or the rate of change of the volume when h is equal to 12. So all we have to do is plug in 12 into this equation. So we have 4 pi times 12. So that's 48 pi times 4 plus 12. And that's underneath the square root. So the 4 plus 12 is 16. Take the square root, that's 4. So we have 48 pi times 4. And I believe this is going to be 190. Oh, no, 192 pi. And now this is going to be the rate of change of the volume. So we have to make sure that we put feet cubed per minute. And that is the rate of change of our volume. Okay. And so now what they want to know is when the height is equal to 12, how fast. One thing, guys, and I don't know if this is going to matter. You know, this is up for debate, I will say. Okay. The height of the grain is given by this. All right. Technically, it's decreasing. Or no, actually, never mind, because it's being filled. I was going to say that this is probably going to be a negative value, but we're good. Okay. So B, when the height is equal to 12, how fast is the rate of change of the height? How fast is the rate of change of the height decreasing? Looks a little weird because they're saying how fast is the rate of change of the height decreasing. So how fast is this decreasing? Okay, this is already a rate of change, but they're asking how fast is that changing? So what we got to do is we got to take the derivative of this. Okay, typically you'll see a problem like this where they tell you what is the rate of change of the rate of change, or how, what's the rate of change of the velocity. And it's a little weird because velocity is the rate of change already, but we have to just understand what they're asking here. So we got to take the derivative of this. So this is my dH dt, 12 root 4 plus h. And now we're going to take the second derivative. I wrote that wrong. My bad. Please excuse me. So now we're going to have 12 times, and we got to know the derivative of this, okay? And it's actually pretty easy. This is just going to be 1 over 2 root 4 plus h, okay? And the reason for that is because the derivative of any root function is 1 over 2 root of the value inside times the derivative of what's inside, which in this case is going to be h, but then don't forget we have to include a dh dt. All right, so when h is equal to 12, we go ahead and plug that in. So 12 times 1 over 2 times, and then 4 plus 12 times dH dt, we already know was going to be 12 times 4 plus 12. Okay? So now what we have is 12 times 1 over 2 times square root of 16 is just 4, times 12, and then square root of 16 is just 4. Okay, so a couple things cancel out. We can't use a calculator here, so we have to just cancel out the 4s, cancel out the 4s. 12 times 12 is 144, divided by 4 is going to be 72. Okay, I agree. The related rates never has a second derivative. However, Dominic, on the AP exam, a lot of the times they'll ask you for a question like this, and we have to take that second derivative. It is annoying, okay? So here we go. Part C. Initially, the container of the grain is empty. Find the expression for h in terms of t. So in other words, what they're trying to tell you is solve for this function in terms of t. All right? So let's go ahead and do that. So we're going to use separation of variables. Let's go ahead and put it somewhere over here. So if y'all remember separation of variables, we have to separate the variables. It's in the name. So we're going to multiply the dt to the other side and then divide this root value to the other side. Okay, and now the reason for that is because we're going to be able to take the integral of this. The right side is going to be pretty easy. That's just going to be 12t plus c, which we're going to figure out the c value in a second. This one technically requires a u substitution. Let me do that real quick. Okay, so I made my u equal to this entire value, and then my du is equal to dh. And so now I have the integral of u to the negative 1/2 du, and that's still equal to 12t plus c. And remember, when we take the integral of this, we have to use power rule. So we add 1 to the power, divide by the power. So this becomes u to the 1/2 divided by 1/2, and that's equal to 12t plus c. And from here, we can just use some fraction manipulation. This 1/2 is just going to become a 2 on the top, and then this was already, now we can go ahead and turn it in terms of h. So we're going to do 4 plus h to the power of 1/2 is equal to 12t plus c. Okay, we're still not done, because one of the things that we have to remember, okay, they told us initially the container grain is empty, meaning that the value of h is just going to be 0 because it's empty. There's nothing to measure. So when t is equal to 0, the height is equal to 0. So we're going to go ahead and plug those values in. So 4 plus 0 to the 1/2 is equal to 12 times 0 plus c. Now, 4 plus 0 to the 1/2, that's just the square root of 4, which is 2. 2 times 2 is 4. So we have 4 equals 12 times 0 is just 0 plus c. So our c value is 4. And I'm sorry, guys, I'm going to have to take you guys in a little trip around this worksheet here. Because now what we're going to do is we have 4 plus h to the 1/2 is equal to 12t plus 4. Because our c value was going to equal to 4. And now the very last thing is we need to solve for h, because remember, they said find the expression for h in terms of t. So let's go ahead and divide the 2 to the other side. 4 plus h to the power of 1/2. And then when we divide the 2, it's 6t plus 2. And we can go ahead and just square both sides to get rid of this power of 1/2, or the square root. So 4 plus h is equal to 6t plus 2 squared. And let's just go ahead and subtract the 4. So h is equal to 6t plus 2 squared minus 4. And voila. That is our problem there. Okay. Yes, for BC, I'm going to do a BC FRQ, a whole video, YouTube video. So I should probably have that by the end of, or the beginning of next week, I would say. So I'm working on an FRQ for AB, because that's typically what most people want, and then I'll do one for BC. And of course, if you guys just have to go, don't forget that I do post these replays on my YouTube channel, so you guys can find that there once we are done. Okay, we got one last problem, guys. We're going to finish this off, and then I'm going to end the live. Hopefully, you guys are enjoying yourselves this late, but let's get to it. Okay, I immediately already see this shape here, and I know that they're probably going to ask me to find the area underneath the curve. And I mean, you cannot believe me, but I already know that they're giving us this, integral here. We're probably going to have to take the derivative of it. We're not worried about it, okay? We know how to do this. So they tell us that the continuous function f is defined on the interval -3 to 10, which is so weird. This is what I'm telling you. I don't know why they do this. The Princeton review is just on crack sometimes. But anyway, the graph on the interval 2, 8 is a semicircle. So they tell us all these things. This is a semicircle. This is a triangle. So they're familiar shapes that we recognize. And then the graph contains a point 3, √5 and crosses the x-axis at the point -3/2, 0. So there, there's no guessing here. We should know those points. Okay? So the very first one, they're saying that the area, if the integral from 0, well, it's a little blurry, I'm sorry. The integral from 0 to 10 is equal to 20. What is the value from 8 to 10? So the whole point here, guys, I guess Princeton Review was not on crack in this case, that there's another function that's standing here. We don't know what it is, okay? It goes to 10. This is 9 and this is 10. I made it up, okay? So don't believe me. There's like some shape. We don't know what it is. But they're saying that if you take the integral from 0 all the way to 10, it equals to 20. So they want us to find what that value from 8 to 10 is. And the way we're going to do that is we're going to find, we know that the area from 0 to 10 of the function, okay, is equal to the integral from 0 to 8 plus the integral from 8 to 10. Artemis, stop it. Sorry, guys, my dog is just barking up a storm here. Okay, we already know this value. We know this is going to be 20 equals, we just got to find this value here, the integral from 0 to 8. And the way we're going to do that is finding the area underneath the curve. Now, from 0 to 2, okay, that's just a triangle. So that's 1/2 times 2 times 3. So this is just going to be 3. And then this right here is a semicircle, a half circle. So it's going to be pi halves r squared. Now, if you look at this, the radius is going to be 3. So really, this is going to be 9 pi over 2. That's the value. So the integral from 0 to 8, which is what we were looking for, is equal to 3 plus 9 pi over 2. And then plus integral from 0 to 10 of f of x dx. And that's exactly what we need to find. So what we're going to do is subtract the 3 to the other side, and then subtract the 9 pi over 2 to the other side. So when I subtract the 3 to the other side, we get 17. So we get 17 minus 9 pi over 2 equals integral from 8 to 10 f of x dx. And there you have it. That is the value that we're asking for in part A. Okay? Now let's go to part B. They want us to evaluate this. Look very carefully. I'll probably even zoom in. It's the integral from 2 to 3 of 4f prime. Come on. Too easy. Light work. Because one thing that I'm going to do is bring the 4 to the other side, or on the outside, because it's just a constant. So we have 4 integral from 2 to 3 of f prime dx. Now you might think, we don't have f prime. We absolutely don't. But we know that the integral of f prime is just f. So according to the first fundamental theorem of calculus, this is literally the original function from 2 to 3. So now we can just do 4 times f of 3 minus f of 2. Now, check this out. F of 3. F of 3 is some value up here. We don't know what it is, but they did tell us that it has the point 3 comma root 5. So our f of 3 is root 5. So down below we have root 5 minus f of 2. So f of 2 is just going to be 0. So then the answer is just 4 root 5. There you have it. That's part B. Okay. So now let's go to part C. If g of x is equal to this integral here, I'll zoom in, negative 3 to x of f of x, find the absolute max between negative 3 and 8. Okay, the absolute max. So remember, for absolute max, we need to plug in the critical point, so when the derivative is equal to 0, and we need to plug in the endpoints. So we need to check a couple things. We need to find what g of negative 3 is and what g of 8 is, because those were our intervals. And now we just need to take the derivative and set it equal to 0. So we got to find the critical point. And how are we going to do that? Well, if you look at this function, when we take the derivative, this is just due to the second fundamental theorem of calculus. This is literally just going to be f of x. Okay, again, that's the second fundamental theorem of calculus. So when we're asking when is g of x equal to 0, we're really asking when is f of x equal to 0. So let's go to our functions. We have a couple. We have negative 3. We have negative 3 halves. We have 2. And then we have 8. Okay, negative 3 and 8 we're not going to worry about because we already know those values, or we're already going to test them. So we need to test negative 3 halves, and we need to test 2. So back to our problem. We need to test negative 3 halves, and we need to test 2. Now remember, how do we test these? Well, g of negative 3 is equal to this integral. So g of negative 3 is the integral from negative 3 to negative 3 of f of x. And guess what? Negative 3 to negative 3. It's the same parameter. This is just going to be equal to 0. Now we're going to do 8. So this is the integral from negative 3 to 8 of f of x dx. Now this is a little tricky because negative 3 to 8, this is literally the area underneath the curve from negative 3 all the way to 8. Okay? We're going to take care of that in a second. I want to take care of some other ones real quick. And you'll see why. Because now we have g of negative 3 halves. So this is the integral from negative 3 to negative 3 halves. So this one's much more easier to manage for now. So I just kind of want to figure that one out now. So the area from negative 3 to negative 3 halves. Well, remember, this is a triangle. So the triangle is 1/2 base. The base is, it looks like it's going to be 1/2 times the height. And the height is negative 1. Now, this is a negative area because we're going downward. Okay? So this is just going to be negative 1/4. All right. So back to this problem, this is going to be negative 1/4. Now remember, we're looking for the absolute maximum, so we can probably eliminate negative 1/4 and perhaps 0. I feel like my answer is going to be 8, but we're going to figure that out in a second. Okay? And so now g of 2 is the integral from negative 3 to 2 of this value. Okay. Back up here. So this is the area of this plus the area of this triangle. Now, luckily for us, we already know this is negative 1/4. Let's just go ahead and find this one. So area is equal to 1/2 times the base, which is in this case is going to be 1, 2, 3, 3.5. So 7 halves times the height, which is going to be 3. Okay, and this looks like it's 21/4. Okay, so our area between negative 3 to 2 is negative 1/4 plus 21/4. And if you add those together, negative 1/4 plus 21/4, that's 20/4, so that's 5. So there we have our value, g of 2. Okay, I did this, or I wanted to do these because now going back to the g of 8, it's the area of this plus the area of the circle. Now, we already know the area of the small triangle plus the large triangle. That's 5. We just did that. So all we're going to do is add that to half of this value right here, which is 9 pi over 2. So g of 8 down here is 5 plus 9 pi over 2, which we found in part, looks like in part A. So which one's the maximum value? More than likely this right here. Now they're asking, find the absolute maximum. So the absolute maximum is going to be 5 plus 9 pi over 2. And then when they're asking justify your answer, we're going to show this work here. And at the end, you just say absolute max is 5 plus 9 pi over 2. There it is. All right, guys, one more problem. And they always like to throw this one, a limit problem here. Okay, so they have the limit as x approaches -1 of 3f of x minus 3 over 2 times x plus 1. Okay, so let's go ahead and do this up here because I have a feeling we're probably going to have to look at our functions. So limit as x approaches -1 of 3f of x minus 3 all over 2 times x plus 1. Okay, well, the first thing we always want to do is go ahead and use direct substitution. So this will be 3f of -1 minus 3 over 2 times -1 plus 1. On the bottom, you can already tell this is going to be 0. No surprise. And on the top, let's figure it out. I think it's going to be 0. Did they tell us what the value of -1 is going to be? Oh, -1 is up here. Geez, they don't really tell us what it is. This is insane how they expect us to know this. I think this is going to be a 1. It looks like it's going to be a 1. And if you have time, notice that this is a linear equation. So you can sort of create the equation for this linear line and then find what the value at -1 is. But I'm almost certain that that's going to be the case. Okay, just because the slope here is 1, 2, 3, 4 over 2. So it's 2, 1. Yeah, that's going to be correct. So this is going to be 1. And honestly, it probably has to, because when this is 1, then you have 3 times 1 minus 3. That's 0. That's kind of what we want, because what they're testing you on is making sure that you are now applying L'Hopital's rule, because we have an indeterminate form. So we're going to take the derivative of the top and take the derivative of the bottom separately. That's what L'Hopital's rule is. Okay, so the derivative of the top is just 3f prime of -1 over the derivative of 2x, or 2 times x plus 1, which is just going to be 2. Okay. And I don't know why I put f prime of -1. I think I'm just already used to this. It's technically f prime of x, and then you plug in -1. But we're going to get the same thing. Okay, so now we got to find the derivative, the slope at -1. We kind of just talked about this. The slope is -2. Or not -2, I'm sorry. It's +2 because you go up 2 over 1. And the way I found that originally is I took this point down below and I found the slope from that point up here. So you went up 4 over 2, so that's going to be 2. So we know that f prime of -1 is just going to be 2. So we have 3 times 2 over 2. That cancels out. And the answer is 3. That's your answer for part D. Okay? Easy points. Easy points. This is a super common question that they love to give when it comes to area. Okay? Now, I'm going to head out, but hopefully you have seen some patterns. And I don't know if you've been studying some of these exams already, but hopefully you start seeing the patterns that come up in these types of problems. All right? And that's going to be it for me, unfortunately. I'm going to head out, but I'll probably go live Wednesday, and then I'm going to go live on Friday, just reviewing these things. And be on the lookout on my YouTube channel for the replay for this video and other videos that I'm going to post involving AP Calc AB and BC. All right, guys, let me just flip this camera so I can say goodbye to y'all. And that's it. I hope you guys have a fantastic night. I'm going to see you guys on Thursday. Be on the lookout on my YouTube channel for the replays and other videos involving FRQs. Until then, take it easy, okay? Love you too, bro. See ya.